Okay, so like I said, we are on this page that we kind of left off on Thursday. Thursday, when we finished, we were talking about pyramids. Now we're going to do our last shape today, which is the cone. A cone is similar to a pyramid in that it only has one base. So when you guys went over pyramids, we only had one base shape and all the faces were triangles. A cone is like that in that it only has one base shape, but what shape is the base for a cone? The circle. Okay, so also a little bit like a cylinder, because a cylinder had circles for bases too. So we're going to kind of talk about how does this work when you're trying to find surface area of a cone. Now, when we talked about surface area of a cylinder, so like even this shape that we went over in class, this container, if I cut my container right here on this edge and I laid it flat, we talked about how the outside edge would make like a rectangle and my bases were circles. When we think about the net for a cone, it's going to look a little bit different because we don't have two circles. So the outside edge of my cone is not going to lay flat as a rectangle. The net for these actually looks a little bit different. So I'm going to draw you what this looks like, and then we'll start talking about the pieces that we need. So a net for the cone, when I think about taking like that outer edge, like that, what looks like almost like the triangle part of it, remember, it's curving around and it's meeting at this point at the top. When you lay that flat, it's not going to make like a rectangle or like a true triangle. It's going to look kind of like a triangle, but a little bit different. I'm going to sketch out what this looks like. You're going to have kind of this curved side to it. And then coming off of each side, you're going to have kind of like these slanted pieces that kind of come up and make a point, something like that. Do your best when you're drawing it. I don't expect these to be perfect, but this is that outer edge of the cone. Think about if you had like a waffle cone, like an ice cream cone in front of you, and you were just going to like lay it out flat and not worry about the circle part yet. That's what it's going to kind of look like. It's kind of like this curved triangle. And then we're having this circle as my base. So I'm going to attach that, and I always draw it right to the left of it. Oops, I don't want it to overlap. So like that. That's what your nets are going to look like for a cone. They look, like I said, a little bit weird. Now, we're going to need a couple of pieces here. In order to actually find surface area, I need to know some measurements from my picture. One of those would be the radius. So your radius from your circle, remember, is center to the edge. So I would need to know that because I need to find the area of my circle. Just thinking about the circle right now, how would we find area of just a circle? Pi r squared. So if I know my radius, I can find the area of the base. Now let's think about the other side, the other part of that net. If I need to find the area of that, I still have to think about the fact that it's curving. So there's still going to be this pi involved. I'm still going to need a pi. And I'm still going to use my radius because just like we did with our cylinder formula, those circles play a part on what that face is going to look like of my net. But there's one more piece that I need, and that's something called the slant height. When you look at a cone, there's two heights that we could potentially have to use. One of them would be the direct, like true height. That would be on the inside of my shape. The other height, which is called the slant height, is on the outside. And we would have talked about this when we went over pyramids as well. In fact, on your bell ringer today, that height that they used for our triangle faces, that was on a slanted side of the pyramid. And so that's your slant height. You'll want to make sure you can tell the difference between the true height and the slant height, because in the next unit, when we start getting into volume, it'll matter which height we use. Sometimes we use slant height and sometimes we have to use the regular height. For surface area, we're only going to need to know what the slant height is. So this side here, I'm going to call S. And again, that would be your slant height, but I would need that in my formula. So down here where I wrote pi r, then we're going to have S next to it for my slant height. So to find the total surface area, I would take the area of my circle plus the area of that face that I laid down flat. So your total surface area formula looks like this. Pi r squared, and then plus pi R S. Pi times radius times my slant height. You don't need the vertical height for surface area. We'll need it in the future, though, to help us find volume. Okay, but we're not there yet. Now, sometimes, though, I'll just give you this as kind of a thing to look out for, because you'll see something like this on your homework today. They may not give you the radius or the slant height. They might give you some information about the height, like the H side, and maybe the radius, but you don't have S. When that happens, remember what you're working with here. This is a right triangle on the inside of this cone. So Pythagorean's theorem could show up. Those special right triangles could still show up when you're maybe trying to figure out what's the slanted side or what's the radius of the shape. Once you have those two things, though, you just go right to your formula and you can start kind of plugging in and solving for it. So let's do an example here together. I want to find the surface area of this cone below. I'm going to first start out by drawing out my net. All right, what is my radius of my net? 7 feet, good. And what's my slant height? Good, 15.7. So using my surface area formula that I had up here, I'm going to go ahead and start plugging this in. So pi times radius squared, we said the radius was 7, so times 7 squared, plus pi times my radius, which is still 7, times my slant height, which is 15.7. What's 7 squared? So this first piece is 49 pi plus, what would be 7 times 15.7? And then I still have my pi. Notice how I'm not calculating with pi, just like we didn't calculate with pi on cylinders or with circles in the past. I'm keeping it the same here. The last thing you should be able to do, though, is combine 49 and the 109.9. If you add those together, what do we get? Good. And then we still have our pi. And how would we label our answer for this one? Good. Feet squared. There's your total answer for surface area. All you need is your radius and your slant height. If you have those two things, you should just be able to plug it in and simplify as much as you can. Do we have questions on the cone?